All right, we're starting chapter 2 with quadratic functions. But before we get to quadratic functions, I want to talk more generally about the definition of a polynomial function. So let n be a non-negative integer. I'm going to stop right there. Why do we say non-negative and not just positive? Because non-negative means positive, but it also means 0. 0 is not considered to be positive or negative. So anyway, let n be a non-negative integer and let a sub n minus 1, all the way down to a sub 2, a sub 1, a sub 0 be real numbers with a sub n not equal to 0. This function, given by f of x equals, so all these a's are coefficients out in front. Their subscripts just correspond to the degree of the term that they're on. So they're saying this leading term can't be 0, otherwise that term doesn't exist. There's no point for that. Anyway, this function is called a polynomial function, and it has a degree n. So degree, little mini vocab word in here for you that we'll be using. Degree is just the largest exponent in the equation. So you're searching every term. It doesn't have to be the first term. It usually is, but it could be anywhere in here. The equation with the term with the highest exponent in the equation is the degree. So we have already talked about linear functions. Linear functions are just polynomial functions, degree 1. So think of polynomial functions as the big umbrella. Linear is a specific type. And today we're going to be talking about quadratic functions, and those are degree 2. Now we talked about cubic, which are degree 3. We talked about those in transformations a little bit, but today's focus is quadratics. So a quadratic function, taking it out of this really general term, if a, b, and c are real numbers, and again, a is not equal to 0, then a quadratic function could look like this. F of x equals ax squared plus bx plus c. That's a quadratic function. I'm saying that it's in general form. Different textbooks call it different things, but general form is this one. We're going to talk about vertex form in a minute. So before we get into all the different things we can do with quadratics, I just want to be sure that we can label the parts and that we get some vocab down. So we should know that quadratic functions have graphs that look like parabolas. The parabola could be opening up or down. It depends on the a value. If a is greater than 0, then the parabola opens up. Again, we kind of have already talked about this because a being greater than 0 versus a less than 0, and x-axis reflection dictates whether we're opening up or down. So if a is less than 0, the parabola opens down. Every parabola has a vertex, and we're going to label the vertex with the coordinates hk in an ordered pair. There is an axis of symmetry that we don't normally graph, but it can be helpful to sketch it in sometimes to generate some more points on your parabola. But this is the axis of symmetry. And that just means if you know there's a point right here on the parabola, you can hop it across the axis of symmetry and sketch the point the same distance away from the axis at the same height. The reason we call the vertex hk is because we could also write a quadratic equation in standard or vertex form. I'll use those two phrases interchangeably. Some textbooks call standard form this general form, so that gets confusing. So just know that for us in this class, standard is vertex. And this is the form of quadratics that we've actually already looked at. It's the form that we use for transformations. So this is where you have y equals, or f of x equals, some dilation a times x minus h squared plus k. And we call that vertex form because it's easy to see right from the form based on how far has the graph been shifted horizontally and vertically. It's easy to see what the vertex is. The vertex is hk. To get other points, we would either plug values in or we would use our knowledge of the shape of parabolas to figure out what the other points are. And so sometimes you'll be asked to convert from general form, ax squared plus bx plus c, to vertex form, a times x minus h squared plus k. And there are two correct ways to do it. I really do not have any preference for which way you learn. The complete the square method is also used for conic sections. We may or may not have time to go back through conic sections. I know you spend a lot of time in our Algebra 2 classes looking at ellipses, hyperbolas, parabolas that open sideways, circles. And so complete the square is important for those things because the vertex formula I'm going to show you would be more complicated for those other conic sections. Okay, so complete the square, useful for conic sections. Vertex formula is usually easier, and I especially use it for applications. We're going to have a lot of quadratic models, and it's going to be easiest to find the vertex, the lowest point, or the highest point, just using the vertex formula rather than trying to complete the square with like messy numbers. Okay, I will show you both. And it is important to know, if fractions are going to be involved, neither one of these two methods avoids fractions. Neither avoids fractions. So don't think like, oh, if I always use the vertex formula, it's going to be way easier. Not necessarily. You're still going to have to work with fractions sometimes. All right, so first we're going to tackle complete the square. Write the quadratic equation in standard form using the complete the square method. I am going to try to write the steps out to the side as I do them. So the very first step, let's do it first and then write it down later. We're always going to keep everything on the right side of the equation. So the first step is to factor whatever a is out of the first two terms, but never the last term. So factor 2 out of the x squared and the 8x. Leave a bit of space. Put the plus 7 on the outside of the parentheses because we did not factor 2 out of them. So for that first step, I'm going to say factor out a from, let's just say, first two terms, assuming the thing is in its standard form, in order, standard polynomial form. Okay, and then step 2 is the actual complete the square step. So after you factored out the a, look at the b value, the b divided by 2 value. So in that position, we're going to take the 4 divided by 2 and square it. So 2 squared is 4. So for step 2, I'm going to say add b divided by 2 squared. All right, now there's another caveat to this. It looks like we just put in a plus 4, but if we were to redistribute the 2, we actually just added 2 times 4. We actually just added 8 to this equation, and you can't just add 8 to an equation. It would change the whole thing, right? If I just add 8, this would be now plus 15. It would change the graph. So to balance that out, whatever we add in, we're going to do the exact opposite of at the end of the equation. So I'm going to subtract 8 to balance that out. If I add 8 and I subtract 8, I've just added 0. Okay, so step 3 is going to be, I'm just going to write balance, balance at the end. Okay. Step 4 is to factor and simplify, and we should have our vertex form. So f of x is equal to, this 2 is still out here, x squared plus 4x plus 4 is going to be a perfect square trinomial. Adding this b over 2 squared creates this perfect square trinomial, meaning it's going to be x plus 2 times x plus 2, or we would write that as x plus 2 squared. And then 7 minus 8, we can simplify that to minus 1. So this is the standard form of our parabola. And we can see that the vertex is, since this has been shifted left 2 and down 1, it's -2, -1. And we wouldn't have been able to see that just by looking at the original f of x equation. So that's the benefit of vertex form. So step 4 is going to be factor and simplify. Whoop, that's weird. Factor and simplify. We need to follow those same steps every time there's something other than +1 in front of the x squared. So step 1 again is factor the a from the first two terms out. So factor this negative out of the first two terms. So that's going to make this, in parentheses, x squared minus 3x. Don't factor it out of the end term, even if there is a nice, like if I were taking a 5 out of everything, even if this number is nicely divisible by a, don't take it out. Okay, now here's where we're going to have a fraction. We need to take -3 divided by 2, square it. So that becomes plus 9/4. So we just did step 2. Now remember, we did not just add 9/4. We actually did -1 times 9/4. So what's the opposite of subtracting 9/4 into an equation? You would add 9/4 to the end of the equation. So that's the balance at the end. And then the last step is to factor. Now, it seems like it's going to be hard when fractions are involved, but the pattern for these perfect square trinomials is whatever you had before you squared this term, so -3/2, that is how this will factor. It should factor into x minus 3/2, the quantity squared. And back here, 4 divided by 2 is 2. Before I squared it, this factored into x plus 2. So it is going to factor into the square root of what you just squared, what you just put in there. Just watch the sign. It's got to be minus because we're trying to get -3 in the middle. Okay, and then 5 plus 9/4. Don't make it 5 and 9/4. That's a weird mixed number. Change 5 to 20/4. And 9 can stay 9/4. And then we have 29/4. All right, so for this one, we could see the vertex would be at +3/2 because that's a shift to the right, 3/2, and +29/4 because that parabola got shifted up that many units. All right, so let's talk about the vertex formula. What is the vertex formula? The vertex formula is kind of just taking that complete the square process and turning it into a formula, basically. So I want to, instead of just telling you what the vertex formula is, maybe you remember it because I know you learned it in Algebra 2. I want to show you where it comes from. So let's derive. So let's say that f of x is equal to, start with your general form, ax squared plus bx plus c. And let's just run through the steps for complete the square. So our next step is supposed to be factor the a out of the first two terms. That's easy to do from here. We just get x squared. Remember, factoring an a out really just means divide those first two terms by a. So instead of plus bx, we're going to have plus b over a times x. And then remember, we don't do that to the plus c. Okay, now what about our complete the square step? So what about this part right here? We're supposed to take the number in front of x, which is b over a, and divide it by 2. Now, instead of dividing by 2, I'm going to think times 1/2. And then we're going to square that. B over 2a squared becomes b squared over 4a squared. Okay, now, did I add b squared over 4a squared? No. If I multiply that by a, I actually just added b squared And then a over 4a squared becomes over 4a. So to balance that out, I'm going to subtract b over 4a. Now you might be seeing like some of these pieces kind of sound like the quadratic formula, and that's true too. It's all connected together, but we're just trying to come up with a vertex formula. So the next step after complete the square and balance is to factor. Remember the factoring rule. Factoring rule is what did you have before you squared this term? You had b over 2a, so it's going to factor into x plus b over 2a squared. And then let's not simplify this. Let's just write this because we're not going to memorize an entire, formula. Okay, but what would the vertex be? The vertex would be from this, because it says plus b over 2a, the x-coordinate would be negative b over 2a. I think of this as the opposite of b over 2a. And then instead of memorizing c minus b over 4a, instead of doing that, remember the vertex will be like whatever number this comes out to, say this comes out to -2. If you just plug that back into the function, you'll get the y-coordinate. So that's why we say the y-coordinate is just f of whatever negative b over 2a comes out to be. Okay, this is something to memorize. Basically, find h. Here's h. H equals that. And then k is equal to whatever f of that is. So find k by plugging in. Okay, so memorize the vertex formula. It will make things easier. Now, I chose the same two equations that we did in examples 1 and 2. I just want to use the vertex formula instead of complete the square. Okay, so the vertex formula is figure out h first. H is the opposite of b over 2 times a. -8 divided by 4 is -2. Let's double check. We did get -2 for the vertex of our first problem. How do I find k? I just evaluate f of -2. Back into here. 2 times squaring it will be 4, plus 8 times -2, plus 7. 8 minus 16 is -8, plus 7, -1. Okay, now the problem wasn't find the vertex though. It says write the equation in standard form using the vertex formula. So what do I have to do? I need to still write the equation. So I can see the vertex is -2 and -1. I can see that the a value is 2. So f of x in its vertex form has to have the 2 out in front. And then it's x minus h, so plus 2 squared, plus k, so -1. Double check, is that what we got for number 1? Because this is the same equation. And it is. Okay, so once you get the hang of this, as long as you're not making little computational errors, this is usually faster. Let's try it with g of x. Find h, the opposite of b over 2a. -3 over -2 is just 3 over 2. So we have a fraction, but again, that's okay. We didn't avoid fractions with complete the square. To find k, you evaluate g of 3 over 2. So we've got this negative here. Square 3 over 2, 9/4, so -9/4, plus 3 times 3 over 2, so plus 9 over 2, plus 5. I would take the time to write out the common denominators. -9 over 4 plus 18 over 4 plus 20 over 4. I just think you're less likely to make a mistake if you just write down an extra step. So this is -9 plus 18 is 9, plus 20 is 29 over 4. And then again, you've got to pay attention to the leading term. The a value is -1, so when we write g of x, we have to write negative parentheses x minus h squared plus k. Let's check that with example 2 to make sure that's what we got. And it is. Okay, so two ways to find a vertex, two ways to write an equation in vertex form. I do not have a preference for what you use. I would like you to use the one that you have the most success with, you make the least computational errors with. What about if we give you some information about the parabola? So given the vertex and a point on the parabola, write the equation of the quadratic function in both standard form and general form. Remember, standard form is hk is visible, general form ax squared plus bx plus c. All right, we're going to start in standard form because if you're given a vertex, that means that you're given an hk. And if you're given a point on the parabola, you're given an x and a y. And so you want to use the equation that has both hk and xy in it. So remember, the generic standard form is y equals a times x minus h squared plus k. We have 4 of these unknown variables so that we can solve for a. The only thing we don't know to write this equation is what is that dilation, that vertical dilation factor. So carefully plug everything in. Y is -6, don't know a. X is 3, minus h, so -1 squared plus 2. Subtract 2 to the left side. Simplify this. 2 squared is 4. Divide by 4. A is -2. Once you figure out a, you can write the standard form equation. So y equals -2 times x minus 1 squared plus 2. How do I get the general form equation? Getting the general form equation is simply like squaring this out and combining terms until you get it to be ax squared plus bx plus c. So y equals -2. We've got to square this binomial, x squared minus 2x plus 1 plus 2. And then we distribute. Oops, I almost didn't distribute. We distribute a -2 through. -2x squared plus 4x minus 2 plus 2. So y equals -2 x squared plus 4x. If I were to graph both of these equations, I should get the same exact graph to overlay itself. And it should have this vertex and this point should be on there. Okay, same thing, different vertex, different point. So here's hk, here's xy. I'm not going to write the generic form over again. I'm just going to use this first line and plug right in. So -4 is y. That equals sum a times -1 minus 3 squared plus 1. Subtract 1 over. -4 squared is 16. Divide by 16. So write your standard form. -5/16 times x minus 3 squared plus 1. There's standard form, vertex form. This one will be a bit annoying to get into general, but we can do it. So y equals -5/16 times x squared minus 6x plus 9 plus 1. That's -5/16 x squared plus, remember to reduce. Don't make it 30 over 16 and then reduce. Reduce 6 over 16. That's 3 over 8. So 3 times 5 is 15 over 8x. I can't reduce 9 over 16, so this is going to be minus 45 over 16. And then don't forget about your plus 1. You might as well make it plus 16 over 16 to be able to combine. So y equals -5/16 x squared plus 15/8 x. And then let's see, what's 45 minus 16? So 45 minus 15 would be 30, so this must be 29, -29 over 16. Okay, we're going to stop there for today, and tomorrow we'll talk about quadratic formula and some applications of quadratics. So that ends our day one. Pick up tomorrow with day two.